Good day, I'm Jamaica Jane. Today I'm going to share to you the calculation process of the concentration of the standard solution after standardization process. But before that, what is standardization process? Standardization is a process of determining the exact concentration or molarity of a solution. Titration is one type of analytical procedure often used in standardization. Next, what is standard solution? Standard solution is a solution with a known concentration of a substance, and it is also used to determine the concentration of an unknown solution. The calculation process. I have here named three basic steps with four step-by-step in solution. What is this? So, the three basic steps I have is the given, we have to know the unknown and the solution. Under the solution, we have the four step by step. One is write a balanced equation for the reaction. Second, find moles of the known solution. Third, use the mole ratio to find moles of the known solution. And last is solve for the concentration of the standard solution. Let's do the calculation. I have a sample problem here. A 20 ml sample of hydrochloric acid was titrated with the 0.0220 molarity sodium hydroxide solution. To reach the endpoint, required 23.72 ml of the sodium hydroxide. Calculate the concentration of the hydrochloric acid. So we have one of the basic steps there is the given. So we have to list the volume of hydrochloric acid, the concentration of the sodium hydroxide, and the volume of sodium hydroxide. The unknown, we have to find or calculate the concentration of hydrochloric acid. Solution. Solution. We have first is we need to write the balance equation. This is because to guide us in the following step. So hydrochloric acid plus sodium hydroxide is lead to sodium chloride plus H2O or the water. Molarity is equals to moles per liter. So this is very important to guide us in our next step. So we have to find the moles of the known solution. To find the moles of the known solution, we have to multiply the volume to the molarity or the concentration so that we can get the moles of sodium hydroxide or the known solution. So we have here 0.02372 liters of sodium hydroxide. So we have to convert 23.72 ml to liters so that we can cancel them out in multiplying them to the concentration of sodium hydroxide times 0.0220 moles of sodium hydroxide per 1 liter. So and equals to 5.218 times 10 to the power of negative 4 moles of sodium hydroxide. So since we get the answer of moles of our known solution, third is we need to use the mole ratio to find the moles of unknown solution. So we have it requires 1 mole of sodium hydroxide requires 1 mole of hydrochloric acid. So we have here 5.218 times 10 to the power of negative 4 moles of sodium hydroxide is multiplied by 1 mole of hydrochloric acid over 1 mole of sodium hydroxide. So 1 mole of sodium hydroxide is put lower so that we can cancel them out to the earlier answer that we get. So is equals to 5.218 times 10 to the power of negative 4 mole of hydrochloric acid. So it's more like one if you have 1-to-1 ratio, you can just change, or you can it's more like you change the mole of sodium hydroxide to mole of hydrochloric acid. But since we are following a calculation process here, we need to put that. So solve for the concentration. To solve the concentration, we just need to divide moles and the volume given of hydrochloric acid. So we have here 5.218 times 10 to the power of negative 4 mole, mole of hydrochloric acid divide. So we need to convert 20 ml to liters. So we have here 0.02 liters of hydrochloric acid is equal to 0.0261 molarity of hydrochloric acid, or the concentration of the hydrochloric acid. So recap, we write the balance equation, we find the moles of known solution, you use the mole of ratio to find the moles of unknown solution, and last, we solve the concentration of the standard solution. That's great. Congrats. A big clap to yourself and myself for explaining it, for sharing it to you. So let's try another. I have a sample problem here, a titration of 0.2121 grams of pure sodium oxalate, 134 grams per mole, required 43.31 ml of potassium permanganate. What is the molar concentration of the potassium permanganate solution? The chemical reaction is 2MnO4 minus plus 5C2O4 2 plus 16H plus is to 2Mn2 plus 10CO2 plus 8H2O. So since the equation is already given, we can just proceed to another step in the solution. So as you can see, you can't see the sodium and potassium in the chemical reaction. Why is that? Compounds with atoms such as sodium and potassium are ionic compounds whose ions dissociate in solution to form cations. So the equation can now be written without the spectator ions. So next is we need to write the given. We have here the grams of sodium oxalate, the molar mass of sodium oxalate, and the volume of potassium permanganate. And we need to find the concentration of potassium permanganate. So for the solution, as I've said earlier, that we need to proceed to the next step, since the chemical reaction is already given. So I have here on the right side, red font, grams per mole is just an equal to milligram per millimole. And molarity is equals to moles per liter, or millimoles per milliliter. So we have here 0.2121 grams of sodium oxalate times 1 millimole over 0.134 grams sodium oxalate. So as you can see, it's not 134 grams, but it's 0.134, because the grams, we need to convert the grams to milligrams so that we can proceed. So the we have a 1.582 millimole of sodium oxalate. Next is 1.582 millimole sodium oxalate is multiplied by the mole ratio we have. So 2:5 because 2 millimole of potassium permanganate requires 5 millimole of sodium oxalate. So we use the 2:5, and multiplying that is, we get an answer of 0.6328 millimole of potassium permanganate. So the millimole of sodium oxalate was cancelled out. So for the next step is solve the concentration of the standard solution. 0.6328 millimole is divided by 43.31 ml potassium permanganate. This is millimole is the as you can see, millimole. I mean the ml is not converted to liters. Since we have millimole, um, you can just input the 43.31 milliliter of potassium permanganate. So we can derive an answer of 0.01461 m molarity of potassium permanganate. So that would be the answer. We find the moles of known solution. Second, we find the moles of unknown solution, and we solve the concentration of the standard solution. So guys, I hope you try this one. Pause the video. Don't forget the significant rules. Write the units in doing the calculation. Don't forget to convert, because also the unit is really play a significant role in calculation process. It will guide you which would you like, which need to cancel out to derive such an answer, or to derive a certain answer. And also always bear in mind that grams should be multiplied by molar mass and volume multiplied by molarity to get the moles of the known solution. So try this one, guys. In 5, 4, 3, 2, 1. So this is the answer. We have 0.02333 molarity of hydrochloric acid. I hope you enjoy this one, and I hope you learned something about this.